Hello students, this is Amuda R, Assistant Professor in the Department of Robotics and Automation. Our subject code is MR3491. Our subject name is Sensors and Instrumentation. So today we are going to discuss about Unit 2 Part 2. That is we are from LVDT. So the next topic is a LVDT. LVDT is a linear variable differential transformer. We can call it as a transformer or transducer. Here transducer means it converts energy into a one type of energy into the another type of energy. Here the LVDT converts the linear motion into the electrical signal, right? So actually it used in many different fields. So this is the construction of a LVDT. Sorry. There is a primary winding and there is a secondary winding. So there is a two secondary winding, one primary winding, that one iron core with a connecting arm, right? So the AC voltage, AC excitation is connected in the primary winding. When I give some AC voltage to the primary winding generates the magnetic field. The magnetic field generates the magnetic flux to secondary windings. So the whole windings are excited now. So now the output is in ideal, right? If the core is moving in right side, then what will happen? So the ES1 is low, ES2 is high. If it moved left side, then ES2 is low, ES1 is high. That is E0 is equal to ES1 minus ES2. Otherwise E0 is equal to ES2 minus ES1. So this is the working operation of the LVDT. So this is what I told now. So this is the characteristics curve. So the linear range is like this. If we take a reading from the LVDT, then it gives the output like this. It gives the curve like this, right? So the advantage of LVDT is high output, low hysteresis, low electrical noise, low power consumption. Sorry. So disadvantage of LVDT is it is a inductive types of transducer. So it is sensitive to stray magnetic field. So hence the extra setup is required to product a stray magnetic field, right? Another one is it's also affected by the vibration and temperature because of it is an electromagnetic device. So the application of LVDT, which is mostly used in automation, aircraft, turbines, satellites, hydraulics, right? So and also it measured the physical quantity, like not only a motion, not only displacement, it also measures the force, tension, pressure, weight, and also it is used as a secondary transducer also. Okay, next one is RVDT. RVDT is nothing but a rotary variable differential transformer. It's same as a LVDT, but the difference is it measures the angular displacement, but that measures the linear displacement. It's a angular displacement. For angular displacement we are using RVDT, which is used in hydraulics. Okay, so the construction is also same as construction working principle. All are the same as a RVDT, LVDT, but small difference is here is a core is attached with the shaft. It looking like a rotating shaft, right? So this is a primary winding, these are two are the secondary winding, which is connected in opposition in a series, right? So same working principle and construction have to write for this RVDT also, right? The advantage of this: durable, low cost, easy to handle, high accuracy, long life, and excellent linearity. So application in which is used in robotics and now modern machine tools, the fuel control system of engines, and also fuel valve, as well as in hydraulics, right? this RVDT is used. So the next topic is a synchro. So this is also a transducer. This synchro, it transforms the angular position of the shaft into the electrical signal. That is, which angular position is converted into the transfer, that is converted into the electrical signal. So which position, so we can see as a electrical signal, and it used as a error detector also, and rotary position, and also a rotary position sensor. The synchro used as a error detection and also a rotary position sensor. Next one is a synchro system types, right? So there is a two types. One is a control type synchro, another one is a torque transmission type synchro. So torque transmission type synchro is a have a small output torque. For a small load, simple load, we use the torque transmission type synchros. For control type synchros, it detects, which is used for a, this control type synchro system used for a error detection in a position control system. So there is a two units, one is a transmitter and another one is a receiver, right? So transmitter, their construction is similar to the three-phase alternator. Here it is, there is a three-phase alternator. So there is a stator and is a rotor coil and also a slip rings. The distance between the angle is 120 degree for these three, right? These three windings, the outer windings, right? The inner winding is a rotor and outer winding is a stator. So this is the construction of a transmitter. So another next topic is a microsync transducer. This is also a sensor, and also we can call it as a variable reluctance transducer. Variable reluctance means it's oppose the magnetic field. It opposes the magnetic flux. Okay, used to a small motion. If I have one shaft, if I rotate for 360 degree means, so where is the error will come? So where is some changes is there? So I can measure the changes in 0.01 degrees, degrees, that is even 0.01 degree I can measure the changes in the angles. So that's why I'm using the microsync transducer, right? So here the diagram of microsync, here is the coil, 4 coils. So outer is a stator, inner ring is a rotor. There is in ion core is there inside of a rotor. So here there is a 4 coils, 1 and 3 is the same and 4 and 2 is the same. If I give some voltage to this rotor, then the output will gives 1 and 3 is same. If it is increases means, and 4 and 2, these two coils have a decreased resistance, and 1 and 3 have a increased resistance. So vice versa. Here is the 1 and 3 is connected to the input voltage, and also a 1 and 2 is connected as a output voltage. The application of microsync transducer are expansively used in application involving the gyroscopes. Gyroscope is a angular measurement device, right? So this is a microsync transducer. The working I have given here, and also I explained it here for the microsync, right? The next topic is a accelerometer. The next topic is accelerometer. Accelerometer sensors are a inertial sensor that measures the changes in a velocity, acceleration of an object over a time. So it measures the some vibration and also a impact and also a tilt. So which are used in our day-to-day life, that is we are used in our mobile phone. So they are used in variety of applications, that is automobiles, smartphones, aircraft, industrial robots, and wearable devices, that is our smartwatch like. So especially they can detect the following, that is tilt, vibration, impact. It measures the inclination of a object, And vibration means it detects the acceleration when object is vibrating, it detects, right? And also it experience an impact. So types of accelerometer sensor: piezoresistive type, servo type, piezoelectric type, capacitive type, frequency change type, right? So these are the types of accelerometer sensor. So piezoresistive means which are used in mobile phones, and servo type means which are used in structural monitoring, that is seismic observation. And piezoelectric type means which are used in automobiles and vibration measurement. And capacitive type means self diagnostic capabilities, that is automotive body control systems. So frequency change type means it measures the frequency, so continually monitoring the frequency. uh, so these are all the topic we have seen today. The accelerometer, microsync, synchro, and RVDT, LVDT. So these are the topics today we have seen. So thank you. If you have any doubts or any questions, drop the comments below. So for more lecture videos, visit our website smit.edu.in. Follow our Facebook page SMIT Chennai. Follow our Instagram page SMIT Official Chennai. Thank you.